Alright, hi chemistry students. This is a video on 10.2 catalysts. And the definition of a catalyst is a substance that is part of a reaction, but is not used up in that reaction. It's only there to speed the reaction up. How a catalyst works is, and how it speeds a reaction up, is it lowers the activation energy for that reaction. And so you can see here, if you have a reaction, remember we can model and show the energy of a reaction via a reaction energy diagram. We have energy on the y-axis, we have time on the x-axis, and what's happening is this shows the energy as we are at our reactants, and what happens is we go to the products. At first energy increases, and remember we said that this is the activation energy, EA. And so there is like a hill we have to climb before we can go down, and remember we're releasing energy here. This is an exothermic reaction to get down to the products, right? And so there is this hill we have to climb. What a catalyst does, it basically creates another way for this reaction to occur, and therefore, we still start at the same place, end at the same place, but we don't have to climb as high as a hill. This is the energy diagram with a catalyst, and so what we can see is that it lowers that activation energy. And so this is how it works. An example of this we did in our lab, right, is when we had the decomposition of hydrogen peroxide into H2O and O2, into water and oxygen. We remember that reaction was going very, very slow. We couldn't see it happening quickly. And so what we did is we added Ki. When we added Ki, remember, immediately we saw a huge amount of bubbles. The reaction occurred very, very quickly. And so that's an example of a catalyst. And sorry, I should have written it like this, right? So what we have is H2O2 and Ki producing H2O plus O2 and Ki at the end, right? And this is how we can see that idea of it's not used up in the reaction, right? Ki is there at the beginning, it's there at the end. Another way we could write this, though, is we sometimes put the catalyst on top like this, and so that's another way of writing it. You might see it like that, and so in either way, you can write it in either way, and this is an example of a reaction with a catalyst. And so some practice problems, right? We can see here, identify the catalyst in each equation. What we can see is actually the same reaction. This reaction can also be catalyzed by manganese oxide. And so here we have manganese oxide on the left. We have it also on the right. It's there at the beginning, it's there at the end. Therefore, MnO2 is our catalyst for 1A. Here, if you have the hypothetical A plus B yields B plus C, right? We have B on the left and we have B on the right, and therefore B is equal to our catalyst for number 2. And then for C, we have H6 plus Cl2 plus Fe yields C6H5Cl plus HCl, classic chlorination reaction. And in this situation, right, we have Fe on both sides, and so Fe is our catalyst. Very nice. And so, that's how you identify a catalyst, see if it's on the left and on the right side. If it doesn't really become part of the reaction, we know that it's a catalyst. And sorry, if it doesn't get involved in the products, right? It doesn't really get used up. And so here it's just telling you, hey, can you draw a potential curve for the presence of a catalyst? And now do know potential, right? Because there's multiple correct answers, right? And so I'm gonna do it in blue because that's what I have, right? But right, you could draw it like this. So that's one possible curve, right? Another one is you could have drawn it like this, right? That's also acceptable. You could have even done this, right? What's only not acceptable, it's not acceptable, right, is if you had gone like above. Okay, so don't do that, okay? But any one of those would have worked. So that's catalyst, pretty easy. Hope that helps. Let me know if you have any questions.